Hi, this is Fixium again, and welcome to the How to Make a Master System Game using Devkit SMS tutorial series number 10. In this tutorial, I go over constants arrays and array pointers. We create a basic implementation of updating player 1, player 2, and high scores data. We also create functions to update player lives and bonus levels information on the heads-up display, or HUD for short. So without further ado, let's begin. Okay, so we're gonna start coding our HUD functions, and there's a variety of ways that we could go about it. The HUD functions will be in charge of updating the scores at the top of the screen, and it will also be in charge of updating the player lives and the current bonus level that we're at. So it has an update at the top of the screen, and the update at the bottom of the screen. There are a variety of ways I could have handled the score portion of it all. We could probably make a string representation of the number for the score, and then maybe divvy it out that way, but I imagine that would be pretty slow. A typical way that scores can be added up, because you have to think that anything that's base 10 or a decimal is going to be hard for the Z80 to do efficiently for each one of those decimals, as they are base 10 numbers, and doing sort of multiplication or anything of that nature on the score, which is 6 digits big, would be a lot of processing power, and it would most likely make our game start moving at a crawl. So it's not practical to use arithmetic to find out the places of each digit. Instead, we can use another method, which is called binary coded decimal, or BCD. And the idea is that you can have a unpacked and packed version. What it means is that you can have a representation of a number from 0 to 9, either as, when they say unpacked, that means you use a full byte to represent that value, or a packed version where it would be 4 bits for each one of the numbers, and in that scenario it's a little more efficient. And there's good details on what binary coded decimal is, or BCD, and the general theory behind it. And then what would happen is, if we were doing packed and we're using 4 bits or a nibble for each one of those values, that you would be able to add and subtract from those values in a binary sense, and then you could get a pattern representation of that number. And that's what we're looking for. We're trying to get it to the point where we are able to display the digits in a very optimized sort of way. And the approach that I take here is more for readability's sake. So it's more in line with a unpacked BCD in a way, although I think the method I'm using here is pretty crude and probably not very optimized, but we're going to take this approach that I'm about to describe here. So what we're going to do is define first all the possible score values that we're going to use within the game. So what we're going to do is you're going to create an array, of all those score values. So these are all the possible score amounts that can happen in a game. And I'm going to put them in this array. And you can see that I'm using unsigned short here because car wouldn't be big enough as we go over the value of 255 here. So we're going to use this constant. That means these are values that will never change, or they cannot be changed. They're just basically in a read-only state. And we're just going to put them in this array. And the reason why we're going to do that is when we go to set certain points, we can just reference this array instead of putting in values or adding values or making it less efficient. So we're going to make a array of constants of every value of point value that we can in the game. So that's what this is. And then what we're going to do is we're going to make value representations of each one of these values that are 6 digits long. So I'll show you that. So here we created these arrays. They're all 6 digits. That's the biggest numbers of digits that the scores can have. So 6 digits big, that's it. And then as you can see here, we are creating essentially character representations of these numbers. Here we're using car for each one of these because none of these are going over 255. So as you can see, 0 would be just 6 zeros. 10 would be represented like this. 50, 100, 400, and so on and so forth. And what we're going to do is these representations, we're going to add each digit when we want to increase the score and to represent that score visually. So that's what we did here. Again, constant, so it's just read only. And then finally, we just have the amounts. So all these arrays, we've made an array of these arrays. So, and we're going to use this to index later when we again go to add the score amounts and to show them visually on the screen. So that's what we did there. The next portion is for the bottom of the screen where we're going to show the extra lives and the bonus level that we are currently. And how we're going to approach that is we're going to define an array of slots that we can put our tile data into. So I'll go into detail about that. So I'm going to grab this code here and I'm going to explain this. So there are 12 slots at the bottom that are 16 by 16 pixels big. And if we go here to tile map and we look at stage 1, what's going to happen is I'm going to slot in different items down here. So right here's where we're going to start slotting them in. So it's going to be 1, 2, 3, 4, 5, so on and so forth until we get to 12. So there's 12 total slots down here that are 4 tiles and width, and 2 tiles width wide, 2 tiles high, and they're both 8, so that means it's 16 pixels by 16 pixels for the graphic, and that graphic is represented by these here. So you can see that the first 4 are not being used and the last 4 are not being used. The first 5 slots are used for the player lives. It goes up to 5 maximum. and then the rest of them are being used for the bonus items as they're being here. So when we count them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total slots that can be filled with any one of these graphics. So we need to define those areas to fill. So what we can do in SMS Tile Studio is come in here and we can select a group of tiles here, and we can go to export selected indexes, export as a decimal, and then we come back in here. I already have them predefined, but just to show you that these numbers are the same, we selected those tile indexes off of SMS Tile Studio, and that's how I defined all these slots. I went through each one of them and I just grabbed them by using export selected indexes, and then I made them as a decimal value to the clipboard. So that's where I got all these. So this essentially is telling us the tile indexes that each one of these slots contains. So, and we did that for all 12, and then much like we did up here, we made an array, pointer array, to those slots. So you can see your HUD slot 0, 1, and so on and so forth. So now we have a pointer array to these arrays that we're going to use later in our HUD functions. So now we have the slots where we can put HUD items. We have our score mounts, what they look like, visual representation of them. And then finally for our data, we're going to actually add the HUD items that we can place into those HUD slots. So here we have HUD banana, HUD pear, HUD apple, pretzel, all the things that we can put on the bottom of the HUD. Miss Pac-Man Player 1, Miss Pac-Man Player 2, because those use different graphics. And then we also have one that's just empty. And these numbers here, the way that I got these are the actual tile IDs. So we can go back into SMS Tile Studio again, and we can, if we look at the main, we can see those graphics are here. So what we can do is just hit for like the first one, which is the banana. You go to banana and we right click and export selected IDs as a decimal. That should be the same as what's here. And it is, if we go over it, 256, 324, 339, and 340. Those are the actual tile IDs. And what I mean by that, as we've seen before, if we show the tile IDs, it shows 256, 324, 339, and 340. And that's all based off of our tile set over here where it's placed at. So, and that's how we get that value. And then I go through each one of them, or went through each one of them, and I did the same thing. I right clicked, select IDs, and then put them in the decimal values and so on and so forth until I filled out every single one. So these are all the possible items that can be placed in these slots. And again, just like the other collections, I make a pointer array, HUD items, of all the arrays that have been already defined. And as you can see, I made these shorts because they're going to go over 255, just like these. The value is over 255. So there's the reason why we picked unsigned short. Next function. This is where we're actually going to set a HUD slot with a with the given slot item or the HUD item. And I'm going to use a for loop for this, and I'm going to start at 0 with the indexer, as we went over last tutorial, and we're only going to do it up to 4. So we're going to increment from 0 to 4. And the 2 arguments that are being sent in here is the desired slot that we want to put the item in, and then the actual item that we want to put in that slot. So here all we're doing is first we're checking to see if the current player, which is a global, is the player 1 or if player 2, so we know which player map to slot that information into. So, and again, this is just the in-memory map. This isn't updating the screen. We're going to do that elsewhere. So here we're just setting up the map with that information. So we're just going to go into the slots, which we have here, and then we're going to pick which slot based off of this. And then this I is our indexer. So what this is doing is indexing through each one of these tiles that were defined in the slot. So it's going to index. So it's going to go to this tile index first, and then this one next, because remember the incrementer increases. So it's going to go to 0, then it's going to go to 1, then 2, and then 3, and then once it hits 4, it becomes false here, and then we'll kick out of the for loop. So what we're basically doing is setting the slot, the index that's given in the slot, with the tile ID that's given in the item. So here we're just setting each one of these tiles with the tile ID that the items have. So it's a 1-for-1. It's going to go and fill 4 tiles based on the slot, based on the current indexer, and that's all that this is really doing, is setting a tile ID for the slot that was given. So, and that's all we're doing here. Set HUD lives. This is going to be the portion that's responsible for actually putting those Pac-Man graphics in. And again, we're going to use a for loop for that. And as I said before, the maximum lives that can be displayed at the bottom of the HUD is 5. So we're going to iterate through each one of those slots. And we have the number of lives that is given in here. So that could be either player 1 or it could be player 2, whatever it may be, what the lives are for that player. We're going to hand that in here. And then the item that we're going to put in. And that can be the reason why we have an item in here, because again, it could be the Miss Pac-Man player 1 HUD item, or it can be player 2. And there is a difference because for player 1, we are using Miss Pac-Man here with the red colors, and then for player 2, it's going to be this blue color. So we may hand in, depending on which map we're on, we may be updating player 1 or player 2. So, and all this does is it checks, okay, is I greater than, so we're going to start at 0. So is I greater than whatever the lives value is. If it is, we're going to actually put a Miss Pac-Man icon in there, or a HUD item in there. If it's not, then we're going to set it to empty. And that's essentially all this does, is it checks if I is greater than the amount of lives, and lives can go down to 0, so that's why we're checking if it's greater. So all we're checking is if I is greater than lives. If it is, then we know that there's a slot that we can fill, and we're going to fill that slot based off of the indexer. So it would be 0, so we're going to fill out the first, second, third, fourth, and fifth slots. These slots, this is where the player lives will be displayed, and then anything beyond that will be the bonus items. So that's why we started at 0, and it works out for us in that sense. This sets the bonus items on the HUD, so the other remaining slots. And it's essentially the same as this, but here we're going to do something a little different. Since the bonus items fill on the right, so when the game first starts, its first stage, cherry is the first one, but these are not present, so these would be empty. So we start from the right, and then as we move on, as we check the indexer to see if it's greater than the current stage we're on, we either have it as empty or we give it the proper bonus level that it is at that point in time. So it's going to actually start at 11. So we're going to start all the way in our last slot. So this last slot is where we're going to start, or visually representation. It would be, since it starts at 0, so 0 to 11, which is the 12th slot. It's going to start all the way over here, and then it's going to go to the left. So this for loop is a little different. So we're going to start at 11, and then we're going to see if it's greater than 4. This is essentially saying, okay, we're going to fill out our slots up to where the player lives are. If you don't want to go into the player live slot, so we want to keep it that I is greater than 4, because remember, everything starts from 0. So from 0 to 4 is actually 5 slots, and those first 5 slots are the player slots. So we don't want to bleed into those slots. We only want the slots after the player lives. So here we're going to check as long as I is greater than 4, because 4 would be the last slot for player lives. As long as that is true, we're going to keep iterating backwards. So as you can see, instead of having plus plus, now we're using this minus minus, which means instead of adding to the indexer, we're actually subtracting. So we start at 11, and then as we roll through our loop, it'll go to 10, and then 9, and 8, 7, 6, 5, and then when it hits 4, it'll bust out, because 4 is not greater than 4. It is equal. So then it will bust out of this for loop and continue the rest of the gaming processing. So now instead of adding, we're now subtracting, and we're putting our index all the way to the right, and we're going to check if I minus 11 is less than or equal to the stage. So it's going to check what stage we're on, and it's going to set the HUD appropriately based on that level that we're at that point. So, and here we're just going to set to the slot. So the current slot would be 11, 10, 9, 8. And then here we're going to subtract 5, because the way that we have our items here, the banana was the first one, so we want to make sure that we don't include the player lives off of that. So it's always going to be 11 minus 5 is going to give us our value. So because of those first 5 slots, we have banana as our first one, and so on, so forth. So just as we move over to the left, it will pick the appropriate HUD item for the bonus slots. This next one is actually adding an amount to the scores array, which is remember those 32 tiles at the top that we talked about before. When we go to stage 1 here, these 34 tiles that we have in memory, or the scores. We did in the last tutorial, we reset them to 0 for player 1 and 2. Here, we're actually going to add the score to this array. Normally, you would use a for loop. It would be a lot easier to do it with a for loop, but this is what is called a unrolled loop. Why do we do this? So it would be a lot easier to define it as a for loop, and as we did here, I mean, it's not much syntax to do so, but sometimes you can get a bit more performance if you take the loop and you manually type it out or write the code out for it, and that's what we're doing here. Normally, what I would do is I would just have a loop for the 6 digits, and then I would do the math in that loop to set the graphic for the score. But I found that was a bit intensive in certain parts, and I wanted it to be a little more efficient. So I took that loop, and I know it's only 6 digits total, so that's what I wrote. I wrote them out manually for every digit. So there's 6 digits here. Normally, again, I would do something with a for loop. It would be a lot cleaner, but I saw that there was a benefit to unrolling the loop and defining each one of these calculations to be done by hand, essentially. So what are we doing here? So the amount index, remember those HUD amounts that we were talking about? So it would pick one of these, whatever the value is. So whatever the value coming in, it would be a number that would be indexed to one of these values here. So the amount index would come in, and then we would pick that amount based off that index. So we're going to get whatever the HUD amount is, and then that array, whatever that may be. So let's say we were trying to add 10 to our current score. So we go into the HUD amounts, and the number that would be handed in for the index would be 1, because 0, 1. So HUD amount 10. So that's the array that we're trying to get a hold of here when we come in there. So if you hand it a 1, it's going to return basically this read-only constant array. So we're going to hand it a 1 here. It's going to go into HUD amounts. It's going to get that 1. And then with this, what we're saying is that pointer to that array, we want to get the last digit in that array, so the 5th digit of that array. So again, since we're using the start, this is actually a pointer or an array of pointers to these, so it's going to point to this array, and then once we get to that array, we're going to go and pick the 5th element. So 0, 1, 2, 3, 4, 5, it would get the 0 out of this array. So that's what we're doing there. So HUD amounts, we're going to go get this array, we're going to get the last digit, and as you can see, we're going to go through all the digits that are in that array. So again, if you pick 1, it's going to go to that 10-point array, and we're going to go and start with the last digit, and then we're going to keep going to the left until we get to the first digit of that array. So here we can see that I said that was the first digit. So, and why do we do this? We're gonna add the score per array element so that we get the correct representation of it. So here we're gonna take that, whatever that last digit is, and then we're gonna go in scores, and again we're gonna have whatever the offset is. So the offset's gonna be whoever or whatever score we're trying to update. So the offset might be player 1 score, it may be the high score, it may be player 2 score. So that's where that offset would be. And what is that offset? So like, as we said before, the player 1's score starts at element 3. So when we look at that, you can go here and it says 0, 1, 2, 3. So that's where player 1's score will be. If it was the high score, as you can see here, based off of what it's shown down here, that would start on the 13th tile. And as we went over this, player 2 starts at the 23rd tile. So the offset that we hand in here would be those one of those three numbers. That would be 3, 13, or 23, I believe was the other one. And since we want to update the last digit of that score, we're going to take whatever the offset is and we're going to add 5 to it. So what that means is if we hand it in for player 1, say it's 3 that we handed in, it's actually when we add 5, it's going to start here. So what that's going to do is it's going to take the last digit of player 1 score and it's going to take the last digit of our 10-point score and it's going to add those together. So in this scenario, they're both 0. So 0 plus 0 equals 0. And that's what that sum is going to be. It's going to be that 0. And again, we can use a car for this because when we add one digit with another digit, it's not going to be more than 255. So that's what we're going to use it. And then what's going to happen is once we add those two end digits together, we're going to see, okay, is it greater than 9? That means that if it's greater than 9, then we have to carry the 1. And we're going to put that here. So if the sum of these two numbers, which aren't at the end, are greater than 9, then we're going to have to add 1 on the next digit going forward. If it's not, in this scenario, it's not, it would be there is no carry. So it's 0 at that point. And then at the end, what we're going to do is we're going to take those we're going to take the end digit of the score and we're going to check, all right, is the sum greater than 9? If so, we're going to subtract 10 to it because it's greater than 9. It has to be at least 10. So we're going to subtract 10 from it. If it's not, so like if the sum is not greater than that, we're just going to use the whatever the sum was. So it would be 0 in this case. And then tile nums, we got our arithmetic here. So we know it's 0. We're going to set the player score, the end score, 0 plus 0 is 0. So we're going to set it to 0 in this scenario. But again, it's not just 0. We have, it's actually a tile ID. So then we add our base tile ID to that, which is 259 here. Why 259? Because that's where the numbers start here. So if we look at the tile IDs and we show them, we said that 259 is where 0 starts. So that's going to be our offset to whatever number is here. So if it's 0, it'll be 259. But if it's 1 and we add 259, then that makes it 260. So then that would show 260 as 1 and so on and so forth. So it shows the correct number, and that's what we set to our scores, which is again our visual representation, our actual tile IDs that are going to represent the score. So this is our offset that we got from the defines, and depending on what number this last digit will be, it will correct it. We'll have the correct tile ID for that. So then we just do the same exact thing for every single digit till we get to the first digit. So we keep going to the left. We started from the 5th digit, then we're going to go over to the 4th digit. So when we go here, so we started here, and then we're going to go to the 4th one, 3rd, 2, 1, 0, until we get to the very last one. And all we're doing is we are one for oneing each digit. We're adding each digit to itself. So when we have 10, we're just going to keep adding the digit based off the place. So where the current score is now, we're going to add that last digit with this last digit. And then once that gets put together, then we're going to go to this digit and we're going to add those two digits together. So here we add 1, and then we would add that to 0 to the player 1 score, because right now it's 0 in theory in this scenario. So now in this situation is, if there was a carry from the last one, we would add that here. We have carry here, but this this isn't even necessary. It could be taken out. But here, if we would have a carry from this first one, we would add it to this. So if there was a carry, it would be, again, we got this from our 10 points one, so it would be 1. And then for the fourth, or I mean the fifth digit here, it'd be 0, so 1. And then if there's a carry, you would add that to, which would be maybe another 1 or whatever. And depending on how much we carry, that will apply to each one of these sums every time we come into it. So so here, with that, we didn't have a carry from last time. We had 0. So when we added the first two, and the last two digits from each one of the arrays, now we're going to look at the second and last digit, or the fifth digit, and we're going to add that together. Here it would be a 1 here from this HUD amount. As we look at HUD amount again, this is a 1 on our next step, and then it would add to 0, saying that, you know, originally our score was 0 across the board. We would add that, so the sum would be 1. Is it greater than 9? No. So then we don't have a carry. And then here, we would actually set the scores at that offset, at that digit, or that, you know, digit place. And then we would do the same thing we did up here. Check if it's over 9. If not, use the sum. If it is, then we want to subtract 10 from it. And so on and so forth. So we want to subtract 10 from it so we can get the correct tile ID based off of this. So this is a conditional on itself. So here we're just checking if we need to have the sum that's there, or if you need to subtract 10 so we can get a 9 out of this. So like, say for instance the sum is 10, it might be, or you know, it would the sum is greater than 9, it might be a 0 for that place, or it might be that that sum is a 9 or something of that nature. So you just want to get that, whatever that digit might be, and then we're going to add our offset based off of that. And again, we're just going to keep doing that. Same thing for each one of them. We're going to check 2 against 2 and put it in 2, 1 against 1 and put it in 1, and then finally the last or the first digit on the left until it sets the scores. Again, this is the visual representation of it. It's not the actual score. It's what is going to be displayed on the screen. This one just updates the top of the HUD, which means the scores. That's all it updates when it's called, and it won't update it if it's not visible. So if the score Y is greater than 16, here it's less than or equal to 16, then we actually do it. If it's greater than 16, as in the viewport is past these first two, so it's not visible on the screen at that point, because as you remember, the viewport is it's 0, 0 here. As it goes down, it accumulates down to 96 maximum. So if we're past these two, we're not going to update the VDP or the graphics on the screen because it's not visible at that point. It only updates these if it's visible. So that's what we're doing here. And we're using the unsafe call to do this. Update HUD top as another call that's continuously made. I don't check for any sort of other conditional other than if it's visible or not. So as long as it's visible, this is one of the first things that is called after vblank. So that's why I can use unsafe. And what I do is just this other define here is the position in our VRAM where this column starts. So the one define I had is that it would start up at this point, and then for the second row, that's the the actual byte number or address of where the tile map of the second row starts. So here I'm saying tile map 32. That means that's the 32nd tile. When we look at it, you can see the index is 32 down here. So when I hover over it, it's 32. So where that starts, I'm going to write our scores array data to it. So again, we use VRAM memcopy 64 because it's 64 bytes, and scores is only 32 tiles, but since it's a short, it's double that amount, so it's 64 bytes total for the data within scores. So that's all we're doing, is we're taking that scores, an entire row, and we're just sending all that data in one shot using the unsafe SMS VRAM copy 64, which means 64 bytes of data written. And much like we did with the update row function from the last tutorial, I am doing the exact same thing here, but I'm using a safe method, as there are times when I need to call a safe method when the stage resets and we are in an active display. And that happens occasionally. So same thing as this one, except we're using the SMS load tile map area. And here again, the X and Y's are actually tile based, so that means the column and row. So we're going to do the first column, which is 0, and then the second row, which is 1. And again, we can get that information if we look over here, and you can see that tile Y is 1, which is our vertical or our row, and position for tile X is 0. So that's how we got this. So 0 and 1, and then we're going to send the same data, the scores array, and then we're going to tell it how many tiles wide it is. So it's 32 tiles wide. This is actual tile sizes, and then the height of the tile is, we're only doing one tile, so one tile high. So that's how we define that. Update HUD bottom. So this is where we set the HUD lives, and then we actually update the graphic area, or and VRAM, we update that area at the very bottom. And so we use safe calls for these because of the way that I use this later. I use this to update when a player lost a life, and then it scrolls down to the bottom. And since it's an active display at that point, I don't use the unsafe methods. And that's okay to do it there because nothing's running at that point. None of the ghosts are on the screen. You're not actually actively playing the game. All you're doing is waiting for the vertical scroll to hit the bottom of the screen. And since that is the only thing we're doing, I don't need it to be blazing fast. I just need it to update the graphics on the VDP or the VRAM. So that's what I use this for. And again, I won't bother updating it if it's not on the screen. So here we're going to wait until it's greater than or equal 80. So how did I get that number? If you remember, scroll Y can go a maximum of 96, right? So the bottom two tiles are the height 8 and 8, so the height is 16. So if we take 16, or we take 96 and we minus 16 from that, it is 80. So we're not going to bother updating the bottom of the HUD unless it's visible. And that's what it's very much the same as this one. We're not going to bother updating the top of the HUD if it's not visible. Here, same deal, but it's at the bottom. And again, we're only interested in updating those two tiles. So we we could make this tile map area again. We're going to get whatever that column, or the current column, which is 0 because we start all the way to the left. And then we're going to get whatever our current row is, because 34 is the last row in the map. So and how I figured that out is this went down here and went here, and then 34 is where it would start. As you can see, is tile Y, it will be 34. So that's how I got that number, because that's where we're going to start updating on that tile. And we have to call this because, again, the scroll will be, it might be in a different position. And if we're over 24, or if we're over 28 in reality, we want to get what the current scroll row is. So that's what we're going to call that. And then here in the player 1 map, we are going to point to where this data exists. So in player 1 map, the start of that data is at 1088. And how did I figure that out? If I go down here and I go to this row, it starts at index 1088. So that's when I'm telling the where the data is starting. Again, I use this ampersand as a pointer to where we're going to start the data, not the entirety of the data. So we're just it's an address to where we're going to start to get that data. And that's what we're doing here. And then we're saying, okay, we want 32 tiles across, and we want it 2 tiles high, because we're trying to get 16 total pixels updated. Again, you can figure that out. This is 32 columns wide, the entire screen, and then we just want these 2 rows, so it'll be 1, 2 rows that we want to update. So that's what we're doing here. And this is doing the exact same thing, but it's doing it for player 2's map when we have player 2 mode enabled. Okay. Add score. I know maybe a little confusing because it looks like we added score here, but actually when we added the mount, this was just for the scores array, or the visual representation of that score. So we just this is what gets updated there. And for add score, you have an index, again, to see which player is being updated, and then the amount index, which is based off our HUD points. So again, we're going to hand it what we need here. So if we're updating with a certain score amount, that's what we want to use for our addition here. So we're gonna check if first we're gonna see if we are over the extra life threshold, whatever that is. So our extra life here was set to, no, it was global, sorry. Globals, we set our extra life to 10,000. So what we're doing is we're gonna check, okay, is the player 1 score, is it less than extra life? And if we would add that amount, I'm sorry, the amount, the HUD points is at the top. I kind of misspoke. So it would be this one here. So these are the actual values. So like, for instance, let's say that we're adding 10 points in. So the amount index is, okay, well, we're going to look for 10 points. We're going to add 10 points. So if we take the player 1 score and we add that 10 points, we're checking, okay, is this over the extra life amount, or is it equal? So is it, when we add these 10 points, is it going to be greater than or equal to what extra life amount is, which is 10,000? If it is, then we add 1 additional life, the extra life, to the player 1 lives, we update the bottom of the HUD if it's visible. Here we set that either it's going to be visually updated, or it will definitely be updated within the actual array, so in memory, but it will update that for us by updating the HUD bottom. Again, if it's visible, it will update the actual graphics, but it will always update the in-memory map with that information. And then we play the audio track for the extra life. Again, we don't want to repeat it. We only want to play it once. And then for the play Warner score, as you know, is from our globals is a long. We actually add that point amount, which would be 10 points here. So we'd add that to the actual player one score. And then we would actually go and add that amount graphically in memory to the score array. And then here, this is just when the player is player 2. As you can see, for player 1, we gave it an index of 3. That's where we're going to start to put this at amount, as we went over before many times. It will be that 0, 1, 2, 3. This is where the start of that index is. And for player 2, it starts at 23. And then once it adds all the score stuff, so this is for player 1, and then else this is for player 2 mode, and it adds all that stuff, what it's going to do is now it's going to check, okay, which one of these scores are higher than the high score, if applicable. And so if the player 1 score is high score, we're going to set that high score to player 1. So we're going to check, okay, is player 1 greater than player 2, and is the player 1 score also better than the current high score that we have in. If it is, we're going to update the high score, which again is the long, with player 1 score. And then all we're going to do is we're going to use this mem copy, which is based off of way back when we went here. There's a string.h. This is a function it provides, which is this mem copy. What we're going to do is we're going to take the scores from player 1, because it starts at 3. We're going to take the scores from player 1 and we're going to copy them over the scores, and the score for the high score, which starts at 13. This starts at 3 because it's player 1, and 13 is where the high score starts. And then we're going to say, okay, copy over 12 bytes. It's only 6 digits, but as you recall, each one of those tiles are 2 bytes. So even though it's 6 digits, it is 2 bytes worth of information. So it's 12 in all. So you're going to copy over 12 bytes for 6 digits, and you're going to overwrite the score for the high score with the player 1 score. And then if this isn't true, then we're going to check the same exact thing for player 2. We're going to check if it's bigger than player 1 score, and we're also going to check if it's bigger than the current high score. And if it is, we're going to make high score to player 2 score instead. And then we're going to do the same copy, but instead of player 1, which starts at 3, and that we're going to use player 2, which starts at 23. Again, when we look at it, this starts at 3. If you look down, it's the tile X. It says tile X3. That's where it starts, and then if we hover over the high score, tile X starts at 13, and then finally for player 2, tile X starts at 23. So then that would denote that we want player 2 score to overwrite the high score, and that's all this does. And lastly, when a stage is restarted or it's loaded for the first time, I typically call set HUD, which will instantiate everything that we need to show right off in the beginning of this stage. So we're going to set all our bonus items. We're going to update the the top of the HUD, which would be our score. So we're going to set our bonus items, update the top of the HUD, and we're going to update the bottom of the HUD with the player lives and anything else that wasn't set from this set bonus items here. Yeah. Set up bottom is just setting the HUD lives. So, and I believe that's it. This was a short one. Hopefully it made some sense. Like I said, some takeaways from this: you don't have to do it this way. I did this for simplicity's sake. There are other concepts to take into consideration that might work better, but the general idea is that we need a visual representation of the scores and an easy way to update those scores through arithmetic. And hopefully I'll see you in the next one.